Hey everyone. The last Genesis triple bypass I did was on a Model 1 VA3, which you may have watched. But I had a second one to do, which I believe is a VA6. And the process ended up being quite a bit different, and I tried a few different things as well. And I felt like there was enough difference to show you something here, like the audio in particular. Let's take a look. So here is the other Model 1 I had to work on. If you saw the previous video, you can tell already that this looks quite a bit different than the result we ended up with on that model. First of all, these are jumper wires that were here to begin with. So these were not part of the mod, and it came from the factory this way. But the mod itself has quite a few differences. Most of them related to audio. As I touched on in the previous video, the Model 1 VA3's audio profile is supposed to be the exemplar, the version that even the triple bypass board strives to be like. So therefore, when we did that motherboard, we sort of cheated a little, I guess you could say, and skipped replacing the audio parts. And instead, we took the output from the audio chip in the corner here and just ran 2 wires and sent them straight out into the DIN through the triple bypass. This is different. This is not a VA3, so here we wired up the full audio, which means that we removed all these capacitors here. There's about, I think, 7 capacitors here, and then we took all of their inputs and wired them in a ribbon to the inputs on the triple bypass so that it can replicate the Genesis sound. Additionally, on the Model 1s, we have the handy headphone jack, right? And if you do this, you remove this jack's ability to produce any sound because you've disabled all the audio production hardware effectively. In order to restore the use of the jack, we had to attach pins. I believe it's 1 and pin 7 on this IC for the right and left. And we wire that all the way back down here and here to the other side of the capacitor we took out. This feeds the output sound back into the headphone jack effectively. So this still works even though we're producing the sound up here now. Other differences I wanted to point out that I thought were interesting though. If you're observant, you might notice that I didn't lift the RGB pins here underneath this jumper wire. In the last video, I talked a lot about how you lift these pins and attach them directly because you're trying to get off of the noisy motherboard trace. But the downside is that these pins are delicate, and I mounted the wires coming off this way across the chip and around, but it wasn't that elegant, and I was always afraid of breaking those pins because, can't say enough, they're super delicate. So I experimented with some ways of doing this alternatively. First, what I tried, let's see if I can, we might need to get the microscope for this. Whoop. I don't want to. Okay, yeah. So they made a bit of a mess here, it looks like, but this was an experiment, so it's okay. First thing I tried was thinking, well, can I attach to these pins without lifting them at all? And yes, I think you could. Excuse me. And yes, I think you could attach to these pins without lifting them at all, but you would need a very small gauge wire, which I didn't have. And it would be a very fine connection to make without bridging. Since when you lift them, you can spread them out a little bit to make it a little easier. Here you wouldn't be able to do that. And this capacitor you're supposed to mount between these 2 points, well, it gets in the way. You could come around and get at them from the back, I suppose, but it wasn't really a lot more elegant. It did save bending the pins, but the bigger problem there is that you still would have these traces connected. And that would mean you'd still be getting the noise from further on, whatever was generating it. So I tried severing the traces, and that might make some of you cringe or recoil. I normally wouldn't like to do such a thing either, but my thinking was that if the pins are to break, that is much harder to repair than simply repairing a trace. And you'll see I did repair these traces. Ultimately, I didn't end up going in that direction simply because of how hard I thought it was to actually get a good connection to these pins in place. But severing the traces seemed like less a severe action than breaking the pins potentially. But I still wasn't super satisfied with that, so I looked further, and each of these RGB traces comes over to here to a via. So what you can see that I did here is I used the grinder tool, whatever the heck it's called, to expose some of the vias, and I soldered the RGB directly to those. Now, of course, that means that you're on the noisy traces again. I'll get to that in a second. I assume we're not probably picking up noise from this short run here, so I'm not too concerned about that. Not an electrical expert, but that seems probably fine to me. And this is an easy connection point to make compared to here. It doesn't involve having to destroy the traces, even if they are easy to fix. And it doesn't risk the pins breaking. So I like this connection point for those reasons. Before I get into the what about the traces question, I want to move over here since we're already here. You might recall I had a problem with a capacitor that went here because on that board this connection point didn't exist. Obviously it does here, but the pin isn't connected in the first place. So I couldn't really figure out why you need to do this, and I ultimately decided to try not doing it at all, because like, why lift this pin if it's not going to benefit us, or try to make the exact right angle with the capacitor to connect it and only it and not bridge anything. Maybe someone can give me a comment as to why they think that this is always recommended, because certainly the install documents don't explain it. But I chose to leave it out, and I certainly couldn't detect any problems having not done this. But anyway, back to the RGB. So what we do have to do to effectively sever these traces when we're using the vias is come around to the back. Let's see. It's a little hard to find the exact right spot. But these vias on the front are here on the back. Sorry, no. Are here on the back. Let me focus that better. So we want to cut this off electrically from the rest of the board as much as possible to avoid picking up any interference, which is the whole point of this. So I removed 3 resistors from here along these paths, and over here removed these 3 resistors as well, which means that none of these paths continue past this point. Now, could it pick up interference just on these traces that are left from where the chip comes and anywhere on here? I suppose so, but I couldn't spot any, and I feel like the installation ease is so much better this way that it may be worth the trade-off of even if there is a small amount. You may feel that removing these resistors is no better than cutting the traces or no better than lifting the pins. I'm not really recommending one method over another here necessarily. I'm sort of presenting the options since they all have pros and cons, but I do think it's unlikely anyone's going to want to remove a mod like this once done. So I think personally I would probably lean towards this method in the future if I were to do this again, you know, without the experimental cutting, of course. And let's see, what else? Not very much more to cover, but in the original mod I showed you the sync cable. We attached pin 42 over here, which wasn't a big deal. We didn't have to lift it or anything, but I found alternate documentation which pointed out that you can just use pin 10 of this IC for sync. I tried that and it seems to work just as well. So it's a nice short cable run, and that's a much easier solder point to hit because it's just plain larger. So I think that's probably a preferable way to go. The only trick I learned was that this chip, for some reason, on different Genesises is, and presumably also Mega Drives, is rotated 180 degrees, meaning that your pin 10 might actually be over here instead of up here. You need to check the orientation of the chip in your specific Genesis or Mega Drive and check the pin labels to make sure you're actually getting 10 and not some other random thing. And finally, I think the only other thing of note here is that on the first one I did, and I didn't forget to do this in the sense that the instructions didn't mention it, but we never connected ground to anything. And for some reason on the VA3, perhaps because we didn't use the audio, we didn't use the onboard audio circuitry, it didn't seem to matter. I mean, I went back and added the ground myself later once I realized this, but on this one, when I first fired it up without ground, the audio was horrendously noisy, scratchy and such. When I double checked everything, I found this ground connection. Sorry, that's blurry. I'm trying to lift it up a little so you can see, but anyway, you can choose any kind of number of points for ground. It doesn't really matter, I don't think. I used the middle leg on this this MOSFET just because it's a nice big chunky point. I suppose you could even use the shielding here if you didn't think it was going to get caught in the casing. Kind of doesn't matter. But anyway, connecting this ground at all removed all the scratchiness I initially had. So why the one model doesn't need it and this one does, I don't know, but it probably ought to be connected in all cases. And I don't know why it's omitted from the instructions I had. And then, I suppose, just before I finish here, let's go back to this other camera. I should probably mention the RF shield. When you're reassembling the Genesis, and I realized this after the last video, if you're going to put this back in, you need to realize that there are overhanging metal parts that are going to come near or directly touch the triple bypass. And that's real bad because you're going to short some of these pins. Some of them are voltage pins. What you need to do is sort of fit it on here, figure out what's going to touch. Certainly this bit, probably some of the overhangs here, and then get, you know, pliers or cutters and fatigue it off or cut it off. If you have rough edge or sharp edges, you might want to file them down so people don't cut themselves. But the main idea is make sure nothing is physically going to touch this once you've reassembled the system, just to avoid shorts. And that's about it. I don't really intend to cover every revision of Genesis I come across with this, but there were a number of differences here, and I wanted to show you the more complicated audio install. So I hope this was somewhat useful, and definitely have a different project for next time. Take care.